Hello my dear students, how are you all? Welcome back to Diksha Karnataka YouTube channel. I hope all of you are doing very good. Today we'll talk about the application of use of substitution in definite integrals. So this is sessions number 7 for our integration, right? Chapter we have done in the previous session, which was chapter session number 6. We have talked about what, Vicha? We have talked about basics understanding of definite integrals. So we defined it, what is it, how it is different from indefinite integral. We also talked about some questions on it, very basic questions we solved in the previous session. In today's session we will see a little bit of advanced question and we will see application of substitution. Okay, how can substitution make our work easier when we are dealing with definite integral? So if you know integrals, you can say that, sir, as we defined in the previous session, what we're going to do, solve any integration. Okay, using what? First step was solve any integration using indefinite integral, and then at the last just use a substitution for the limits. Okay, upper limit minus lower limit. But we'll see the approach when we use for substitution in the definite integral in today's session as well. So let's get ready and let's start the session. If you need to have some water, if you need to take some break before starting the session, do that right now, because once we start, we'll complete the entire session in one go. Reason, sir, because if you are here, if you're watching the video, then you must complete the chapter, this particular topic, this practice of the questions on the substitution of different integrals in one shot only. If the questions are getting lengthier, if you're not able to understand it, do one thing, pause the video, whatever you can solve from your end, then continue with the solution. You'll understand by creating relevance from your own answer. If you make your own mistakes while solving the problem, no, when I'm trying to explain something, you'll get the answer clearly in your mind. Okay, so if you need to pause the videos, get your own solution, whether right or wrong doesn't matter, then come back and see the correct solution with me over here. So let's start. Please take your pen and paper out and let's start with the session. Okay, so what is the first thing? Evaluation of the definite integral by substitution. So first of all, when can we apply substitution everywhere? Yes, actually most of the time we can apply, but what is the best suitable condition to apply substitution? So the thing is, if the integration itself is having what? Is having the differentiation of the substitution present in it. Let's say I'm taking some function I'm taking as t or taking as y or some other variable I'm applying to the substitution, then the derivative of that function should be existing in the given expression or given integration that we have to evaluate. So let's have a look. So over here, if you see, if I take this gx as t, then what is happening, Bacha? This g dash x is present here, correct? No, means derivative of the function that I am substituting for should be present in the function, then it will become very easier to take the substitution. This is the condition that we have to consider while taking the substitution, right? I think we have used it in the previous cases also. Over here also same thing. Okay, substitution is used when the derivative is present, in the question. Okay, chali, in the integration. All right, what is this called as? If you remember, this is called as upper limit, this is called as lower limit. Am I right? Yes. Okay, so upper limit and lower limit is given like this, no problem there. Chali, now so I can transform this function as what, Bacha? Acha, one more thing, very important thing. Okay, one way to solve any definite integral is what? Solve the indefinite integral and at last keep the same variable. After substitution, what happens? You have to switch back the variable, get the same variable. Therefore that this limit was given, right? Okay, for x the limit is given as a and b. Okay, so use the same variable, solve the integration without considering what? Definite condition, just solve the indefinite integral, at last use the limits. One way to do that. Other way to do it is, okay, you have to change the limit also. It means that, see, I'm changing the function, there's a substitution here, putting gx equals to t. Okay, if you put t as gx, Bacha, tell me, okay, how will you take the derivative? Why we need derivative, sir? Because there's a dx over here. I have to replace that with dt, no? Because the function, if I'm changing the function, check here, after transforming, this will become what? Integral of the limit we will consider later. This will become what? F of t. Okay, f of t. Okay, and this, what will we have? We have this g dash of x dx. Isn't this contradicting? Please check here. The function is defined in the variable t, but this xx is present here. It means I have to check that also out. How do we do that? So over here, Bacha, what we do is we differentiate t. We get it as dt by dx. Correct, na? That's how we differentiate t with respect to x. And what will this be, RHS? Simply g dash of x. Yes or no? Yes. Now take this dx on the other side. What are you going to get? Please check. I'll get as dt equals to g dash of x dx. Now if you see here this thing, I can replace now with f of t simply dt. Okay, this is how the substitution is used since the derivative is present in the function. That's why substitution is used only if derivative is present. Now second condition, check here, when x was a, I'll replace, what is my t? My t is gx, right? My t is gx. Please have a look. Okay, this is very, very important. I want all of your attention on the board right now. When x is a, what will happen to gx, bacha? Tell me. It will become what? G of a or not? Correct. I'll replace x with a, so it will become g of a. Same way, when x is b, it will become what? G of b. And what is gx? Is t. So basically, when x is equal to a, my t value is going to be g of a, and when x is equal to what, bacha? Is equal to b, my t value is going to be g of b. Yes or no? Yes, sir. That's why I can simply write the limits as, instead of a, I can write here what? Simply g of a. Instead of b, I can write it as what? G of b, sir. So lower limit will become g of a, upper limit will be g of b. If you want, I can rewrite this over here for your understanding. So my lower limit will be what? The value of the function g of a and g of b. The function becomes what? F of t dt. This is when I've taken t equals to gx. Okay, very, very simple. This has to be done. You have to transform the limit. Otherwise, you cannot use, let's say, think about it. No, the variable has been changed, but the limit is not changed. Then you apply the previous variable's limit to the next. For example, let's say, I'll give you an example. Let's say, I have a condition like this: tan x sec square x dx is there. Okay, what's the value I can take for x? Tell me. X I can take to be angle, right? X I can take to be angle. So let's say it is given from 0 to pi by 4. 0 to pi by 4. Okay. Over here, how will you take this substitution? Take this as t. So if you take this as t, it will become what? T equals to tan x, right? Differentiate, bacha, will become what? dt by dx equals to sec square x. Cross multiply here, you will get what? Transform this here, you will get what? dt equals to sec square x dx. Yes or no? Yes. Now replace this whole thing as this. Tan x will become what? T. Okay. And how much is this? Simply dt. Now tell me, if you integrate this value, these values, what are you gonna get? You should get a number, no? But instead, if you take this limit 0 to pi by 4, you're gonna end up with angles. Please understand this. Why is the angle, sir? Because the integration of this is what? T square by 2. What is the limit? 0 to pi by 4. So I'm trying to give you a condition where I'm making a mistake and explaining you why this is a mistake. Okay, so please pay attention. I am making this mistake on purpose. Okay, think about it. I am getting this result. What is the value of tan x? X will be angle, but tan will be a value, right? X is the angle which goes in, which is the domain is what? Domain of tan and sec is what? Angles. Whereas the value which is coming out is what? It's a value. So it's a value. It can be any real number. Okay, for any real number. But if you do not transform this limit, what are you going to get? You're going to get pi by 4 the square by 2. What is that? It's an angle. So you're getting a wrong result because you did not transform the limits. Let me transform the limit for you. What's the condition? Tell me. The condition was x from 0 to pi by 4. So when x is 0, what's the substitution? T equals to tan x. It will also be 0, bacha. Think about it. When x is 0, what is tan x? Tan 0 will be 0 only. Sir, it is not making change. You will see now. When x is pi by 4, what's my t value, sir? Tan of pi by 4. And how much is that, sir? Simply 1. So if you transform the limit, if you say that this is incorrect, I'll write it here as 1. Now you check here. This is incorrect, so write it here as 1. Okay, 1. What is my answer, bacha? My answer will come as 1 square by 2. How much is that? 1 by 2. Now is this same as pi square by 16 into 2, pi square 32? If you take pi by 4, you will get what? Pi square by 32. And this is 1 by 2. See the difference in the answer. So you have to change the limits if you are changing or using the substitution, using the change of variables. Okay, variable is changing substitution. You have to change the limits. Very, very important. Okay, chaliye. You might have this question, sir, why is 0 not changing? Because 0 angle or 0 of any quantity will have no difference, right? 0 of any quantity, whether it is angle or a real number, okay? That's why 0 is not making a difference over here, but in this case you can see pi by 4 and 1 has a big difference. Pi by 4 is an angle, 1 I am taking as a real number. Chaliye, moving on. The same thing, it should be noted that whenever a variable of integration changes, limit of the integration also changes. This limit is not like the limit, sir, this limit extends to 0. This is not that condition, bacha. Limit means what? What is the meaning of this limit? Upper limit and lower limit in the integration, upper limit and lower limit, not the limits, okay? That's not what we are talking about, this limit, upper limit and lower limit we are talking about. No confusion here. Let's see the question, and I hope you'll understand this. I hope this is visible. I just took an example to make you understand how can taking a wrong limit give me a wrong answer. Sorry, how can not changing the limit will give me a wrong answer, and changing the limit will give me right answer. And how we change it, bacha? Take this x, use the substitution variable, get the value for the t, same way, change the upper limit for get the value for the variable t, okay? Simple enough. Chaliye, aage badhte hain. First problem, sir, how will we solve it, sir? First thing is, we have to use substitution, we'll see what we can do. Right now, acha, one more thing, reason for substitution, no, because very complicated question will become much simpler if you are using substitution, okay? And becomes very, very easily integratable, okay? Let's see now. So look at this question, x square upon a square plus x square, the power 5 by 2 is there in denominator. Power 5 by 2 is in denominator. The limit condition is 0 to infinity. So one thing is for sure, that we have to, transform the using substitution, certain substitution, and also change the limits, sir. Okay, fine. What can we do? We can take x as, so what we're going to do first thing, no? We'll take the limit substitution first and take the limit change also there only, so that no confusion that itself. So x, because some people will have this this habit, students will have this habit, sir, we need a limit at the last, sir. Why we have to change it in the beginning? Because you might forget it, you might make a mistake for solving it at the end. So it's very important to get the limits in the beginning only. It's a small thing, not big deal, right? We'll see now. So x equals to, I'm going to take, bacha, let's see it as a tan theta. How? I've done a session on only substitution of the, substitution, how to use what substitutions. Go ahead, watch in my playlist for the substitution, what substitution to use in what conditions, okay? So a square, see this will become identity, no, that's why I'm using the substitution. This will become what? A square, this will become what? A square tan square theta. I can take a square common, it will become what? 1 plus tan square theta. It will become what? Sec square theta. 1 by 2 is there, 5 by 2 is there, right? They will become root, no? So for that reason, I can take sec square theta out. So for that reason, I'm doing this, okay? Now x equals to a tan theta is my condition. Substitution here, please have a look. Okay. Change of the limit has to be there. First differentiate it, so I'll get what? If I differentiate this, have a look, I'll get what? 1, I'll get 1 first. 1 equals to, a will is constant, so sec square theta d theta upon dx. The chain rule is there, bacha. Take dx on this side, you'll get what, bacha? Tell me, dx equals to a sec square theta d theta. Am I right? Any confusion over here? How did I get this part? No? Please comment if you have any confusion, how to identify d theta by dx also, okay? Chaliye, moving on, change of limits. So when x is what? First check for lower limit, please check lower limit. X is 0. When x is 0, bacha, what is my, okay, what is my this part going to be? Tell me. It's going to be a tan of 0. It will become what? A tan of 0, right or not? So I can write it as simply 0, because tan 0 is 0, right? So a tan of 0 is 0. What about the other condition? Okay. Acha, one more thing. I have to find for theta inverse, no? There's a change here. Okay. Yeah. Please have a look. I have to find the value of theta, right? Because I'm applying the limit on the variable theta now. Okay. So how will I do that? It will become x upon a equals to tan theta. So it will become what? Tan inverse of x upon a equals to what? Theta. Now you check here. Now substitute the value of x. you'll get what? Tan inverse of 0 equals to theta. How much is that? Simply 0. Simply 0. Okay, because tan inverse of 0 is 0. What was the next condition? Infinity is there, infinity. Okay, so again we'll use this condition. So theta equals to tan inverse of x by a. So theta equals to simply what? Tan inverse of theta, sorry, infinity. And how much is that? Theta equals to pi by 2. This is my what? This is my upper limit. Upper limit. Okay, let's apply it over here. My integration I will transform now to, please check, 0 to pi by 2. 0 to pi by 2. X square is there. What will this become? So a square tan square theta. Okay, what is dx value? A sec square theta d theta. So a sec square theta d theta upon what, bachcha? Tell me here. A square plus a square tan square theta. Please have a look. I am taking x as a tan theta in the denominator also. Okay. Power is how much, bachcha? Power is 5 by 2. 5 by 2. Okay, let's see this. Same thing will remain here. Okay. What is this? A and a square will be what, bachcha? So a cube. How much is this? Tan square theta sec square theta. Again what? D theta will come. What does this tell me here? I get a square common, right? So if I take a square common, it will become what? A square times of 1 plus tan square theta, the whole power 5 by 2. Yes, let's take the last step over here in this page only, this slide only. I'll get what? Same limit, 0 to pi by 2, 0 to pi by 2. Please check, numerator will remain same, a cube tan square theta sec square theta upon, now please have a look. Applying this thing, I am taking this whole root now. What will this become? Please have a look. This whole thing will become a square 1 plus sec tan square is how much? Sec square. So I can write it as a sec theta the whole square and this whole thing to the power 5 by 2. I will repeat this as that's why there is no confusion. See, a square is a square, 1 plus tan square is going to be sec square theta, okay, from the identity of the trigonometry. This will become what? A square sec square. I am writing it as a sec theta the whole square. Why, sir? Why that, sir? Because I can cancel this 2 and this 2. This 2 and this 2. What is left now? A power 5 sec power 5. You will see the transformation now. So I can write this over here, my integration as, please have a look. This will become what? I equals to, how much is this? 0 to pi by 2. 0 to pi by 2, no confusion there. It's not a by 2, it's pi by 2. Okay. What is the numerator? A cube how much is this? A power 5 sec power 5 theta. Why power 5, sir? Because square and square will cancel, right? Power rule I am using for the exponent. So 2 times of 5 by 2 is simply 5. Now have a look. A cube will cancel this. So I will have what left? 2 here. A square is left here. What about this? Sec square will cancel this. I will have what left here? 3 is left here. Yes, okay. Chaliye. Let's have a look again. 0 to pi by 2. 0 to pi by 2 was here, bacha, is 1 by a square. I can take it outside. The constant number 1 by a square is taken outside. Okay. This will become tan square is there, no? So sin square theta by cos square theta times of sec cube theta d theta. So please check, out of this sec cube, I can take sec square with cos square as 1 because cos and sec are reciprocal. So sec square and cos square is 1. Okay. So this I will get it as 1 by a square 0 to pi by 2. What I am going to get, bacha? Please tell me. Sin square theta. Okay. What is that now? Simply sec theta. How come, sir? Cos square over here, sec square over here. From here, sec square will become 1 and this 1, it's sec cube, right? This sec power 3. I have 1 sec left. I can take this in numerator, will become what? Simply cos. So let me write it over here. It will become simply cos theta d theta. Let me erase the denominator. No problem there? No problem, sir. Okay, sir. चलिए आगे बढ़ते हैं. Okay. Now I have sin square theta cos theta. Okay. Now see this, I'll use another substitution. I'll take this as t equals to sine theta now. T equals to sine theta now. Please check what is the differentiation now. dt by dx equals to cos theta. So what is this? dt equals to dx cos theta. Check here, I have, okay, one mistake. I have taken x, bacha. It should be d theta, no? It should be d theta, right? Yeah. Yes, sir. This would be d theta. This would be t only. This would be d theta. Please have a look. I have the same thing over here. I can replace that, but before going to that, I have to change the limit again. So what is this? When theta is 0, excuse me, what is my t? Sine theta. Sine of 0. How much is that? Simply 0. When theta is pi by 2, when theta is pi by 2, bacha, the upper limit, what's my t? T is sine pi by 2. How much is that? 1. So this is my lower limit and this is my upper limit. Any problem there? No? Okay. Let me transform the integration now again. So my integration, same integration becomes like this. 0 to 1, upper limit is 1, lower limit is 0, okay, and this will become what? 1 by a square is a constant, I'll keep it outside, okay. Sine square theta is there, right? So it becomes t square, and this whole thing will become what? Simply dt. This is the simplest integration ever, right? Check here. After this process, I get this simply as t cube by 3, yes, t cube by 3. I'll take the 3 constant outside, 3a square. What's the limit? 0 to 1. So t cube to the limit 0 to 1. What's my answer, bacha? Tell me. Upper limit minus lower limit we do. So 1 cube minus 0 cube. Upper limit minus lower limit of the function. Okay. So I get was 1 by 3 a square is my final answer. Sir, very lengthy. I know. Sometimes the question will be like that. I told you in the previous session we took very simple questions. Over here we have taken some advanced questions to deal with all the concepts of different integral. I think we'll have one more session on different integral where we'll talk about properties of different integral, okay. But for now, let's see this question. So I hope this is visible to all of you, okay, from the very beginning. Yes, moving on, have a look. Yes, final answer is 1 by 3 a square, because this is a minus 1, right? This is 1 minus 0, which is how much? 1 only. 1 cube is 1, 0 is nothing. So 1 minus 0 is 0, sorry 1. So answer is 1 by 3 a square. Moving on to next question, number 2. Integrate from in the limit 0 to pi by 4 provided that dx upon cos cube x. Very good question. Very good question. We'll see. Okay. We'll have to use the formulas of trigonometry also. Okay. So let's see. First we're going to do what? Before I transform, have to use what? Get rid of the root. So let's see what we can do. I can see there is a sine 2x here. It means I can write it as 2 sin x cos x. Let's do that straight away. So my integration if I assume it like this to be 0 to upper limit is pi by 4. What is the bacha? Dx upon cos cube of x, okay. 2 is there, and sin 2x is what? Sin 2x is 2 sin x cos x. Acha, this should not be doubt that, sir, why there is 2. This should not be a doubt, sir, why there is 2 2's? 2 2's because 1 2 is already present in the question, in the expression, okay. This is the formula of sin 2x, 2 sin x cos x, no doubt there, okay. Chaliye, 2 into 2 will become what? 4. I can take 4 out of the root as simply 2. This is a constant denominator, this is simply 2. Whole thing is in the multiplication. I can take this 2 common outside. Think about it. 2 times 2 is 4, in the root will come out as 2. Whole thing is in multiplication. I can take simply 2 outside the integral as 1 by 2 because it is in denominator. 0 to pi by 4. Now have a look. Dx is there. What about this? Please have a look. This will become cos cube x times of sine 1 by 2x. Sir, why like this? Sir, 1 by 2 is not visible. Okay, let me rewrite this, bacha. So 1 by 2 of x, okay, and same thing I can do for cos also. So cos of 1 by 2 of x. Am I right? 1 by 2 of x, because root is there, no? So 1 by 2 I can write. I am doing this because I want to club the causes together. Let's see. So I get 1 equals to 1 by 2 integration from what? 0 to pi by 4. Am I right? Pi by 4. Okay. This will become what, bacha? Dx. Sir, why not changing the limits? I have not changed the substitution so far. Only I am simplifying the condition which is given. This will become what? Cos to the power 3, cos to the power 1 by 2. Same base, add the exponent. So it will become what? Cos of 3 plus 1 by 2 of x, and sign will remain as it is. Sign will remain as it is. So let me just do one thing. I can see, bacha, that there is cos in the denominator. It will become sec somehow if I take it up. Okay. And I have only sign here. If I divide this sign with another cos 1 by 2, with another cos 1 by 2, I'll get what? This bracket will become what? Tan x or not? Yes. So I'm taking something extra. In the division, over here I have to multiply the same thing over here. So cos of, okay, I'm multiplying the same thing over there. So cos of what? Tell me. I've taken here cos of 1 by 2x here. So same thing I'll write here, cos of 1 by 2x. Okay, 1 by 2x. Now if you check here, what is the transformed value? My transformed value, I'll write it over there, is nothing but integration I is equals to 1 by 2 is a constant, integration like this, from where to where? Same thing, 0 to pi by 4, no change over here at all. Dx will again be the same thing. Okay. Now please have a look. Please have a look. Cos is here and cos is here also. Cos here and here. I can take the cos together, write it as cos to the power, check here, 3 plus 1 by 2. Okay, sir. 3 plus 1 by 2. Okay, sir. Plus this also is 1 by 2, no? So I'll take this as plus another 1 by 2. Okay. And what is this? Simply tan of tan to power 1 by 2. Okay. This will become what? 3 plus 1 by 2 plus 1 by 2. Half plus half is 1, so 3 plus 1 will be 4. This will become what? Simply power 4. I'll take it in the numerator. Please have a look. I'll take it in the numerator directly. So my integration I will become what, bacha? 1 by 2 from 0 to pi by 4. 0 to pi by 4. This will be simply what? Cos. No, cos is going up, right? It will become sec. No, sir. Forgive me, sir. Sec power 4 theta d, not theta, x. Okay. I've forgotten to write here the variable. This here also has x in it, so x dx. Okay. Cos has gone up, so sec. What is left here? Root of tan x. Why root of tan x, sir? Because power 1 by 2 is there. Power 1 by 2 is there, bacha. This is 1 by 2. Power 1 by 2. 1 by 2 means what? Root only. Okay. Power 1 by 2 means root only. Now please differentiate this x square as I equals to 1 by 2. Same thing. 0 to pi by 4. And that is as sec square x times of sec square x dx upon root tan x. Root tan x. Okay. Now I'll take the substitution. Okay. So let me write it over here on the next slide, the same thing. Then you'll see. So I can take this like this over here. Okay. So I'm taking my integration I as 1 by 2 is the constant which is outside, 0 to pi by 4 or 2. Pi by 4. 0 to pi by 4 is there. Okay, 0 to pi by 4. This is nothing but sec square x times of sec square x upon root of tan x dx. Yes, okay. Now take this sec square. I'll change this now. I'll show you. Now the substitution will come. So I'll take tan x equals to t. Tan x equals to t. Okay. Take the differentiation, bacha. So d of this, if I take this, it will become what? Please have a look. It will become sec square of x equals to dt by dx. So from here what I get? Sec square x times of dx equals to dt. I can club these two together. Okay. And what about this sec square? I can write it as, actually before going to the question, let's change the limits. So what is this lower limit going to be, bacha? lower limit was when x was 0. What is my t? T is tan of 0. How much is that? 0. Upper limit, please check. Upper limit when x is pi by 4. What's my t? T is tan of pi by 4. How much is that? Tan of pi by 4 is how much? Simply 1. So my limit is transformed now. Okay, upper limit, both limit, and I can write the integration I as 1 by 2 is constant starting from 0 to 1, because limit is, upper limit is 1, lower limit is 0, so 0 to 1. Function 1 plus sec square will become what? Sorry, sec square will become what? 1 plus tan square x, okay, and this is what simply dt upon what? This is root t. Have a look. I am writing sec square as 1 plus tan square x, and I can write tan square as what? T square, because tan x is t, I can write this as simply t square, sir. Okay, I am writing this simply as t square, sir. Okay, root tan x means root t. Alright, now what I am going to do, separate the 2 with the plus sign. This is a plus sign of 1 plus t square, so I will separate it. It will become what? My integration I will look like 1 by 2 is constant outside, 0 to 1, okay, 1 by root t, okay, plus t square by root t dt, t square by root t dt. Okay, please have a look. The constant 1 by 2 is outside. If I integrate, what is this going to be, bachcha? Tell me. Over here, simply what? Root t upon 1 by 2. Because root t is in denominator means what? T power minus 1 by 2. If you add 1 to it, it will become what? Minus 1 by 2 plus 1. How much is that? 1 by 2. So 1 by 2 means root again. Same thing you write with the division in this constant. This formula, x power n integration is what? X power n plus 1 upon n plus 1. What is n in this case? Root t is in denominator means minus 1 by 2. So if you do that, it will become what? Minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 with the power x or t, whatever it is. It will become what? X power 1 by 2 upon 1 by 2. Same thing is written over here. X power 1 by 2 is root x. Okay, chali. Just giving reference because first I am using this formula in this session today. Otherwise, you should be able to recall this. Yes? Yes? Chali. Okay, moving on. So this is true. What about this? I have to divide, it will become what? So this integration is done. Okay, this integration is done over here. So I'll write the limit from 0 to 1. Okay, 0 to 1. What about this one? It will become what? Integration of, it will become integration of 1 by 2 is to there outside. Alright, this will become t power 2 minus 1 by 2. How much is that? 3 by 2. T power 3 by 2 dt. Limit remains same, 0 to 1. Okay, you will see this. I will add the limit over here, the first one. It will become what? Root of 1. So I can take this 1 by 2 here as 2 in the numerator. It will become what? 2 root t. The limit remains same from 0 to 1. Okay, plus what is the integration of this? T power 3 by 2 plus 1 upon t power 3 by 2 plus 1. 3 by 2 plus 1. Okay, this over here also limit 0 to 1. This whole thing is closed. 1 by 2, please have a look. This will become what, bacha? For the upper limit, 2 times of root of 1 is how much? Simply 1. And for lower limit, minus 2 times of what? 0. So 0 root is 0 only. What about this condition? Over here, t power 5 by 2. So again, this will become what? 5 by 2, no? 5 by 2. So I can write it as 2 by 5. Please check. This is 3 by 2 plus 1, 5 by 2. Okay. So 2 by 5 because it's in denominator, so 2 by 5. What about this condition? It will become what? T power 5 by 2. So 1 power 5 by 2 minus 0. Okay. Please check here. I am getting the answer as 1 by 2, 2 minus 0 plus 2 by 5. Yes, because this is again 1 minus 0 is the same thing. Take the 2 common, cancel this 2, 2 and 2 gone. What I have left now? Simply 1 plus 1 by 5. How much is that, bacha? 5 plus 1, 6 by 5. 6 by 5 is my final answer. My final answer is this, bacha. Complicated, but I don't think so that much. Simple only, little bit of things are there. Please have a look. I hope this is visible. Okay. First we use this formula for from the sin 2x. because substitution, then I used what? Simplified sine and tan. Then for this I got this form, then I use my substitution, transform the limits, upper limit, lower limit, got the integration done, and this is my final answer, 6/5. Okay, visible. Moving on, question number 3. Over here what we can do, so we have to use the by parts only, no? See, so in the integration of what? In the integration of different definite kind also, we have all the different kinds of indefinite integrals involved as well. So you must have the learnings and the understanding from the previous concepts to be able to solve the questions in this different integrals. Okay, so eyelet we have to apply in the by parts. Eyelet, sir, eyelet. So trigonometric functions will have a preference, sorry, log will have preference. This is my function 1, this is my function 2. Okay, applying by parts now. Please have a look. What's the condition of by parts? I'll keep my limits as it is for now. So condition is what? Pi by 4. Pi by 4 to what? Pi by 2. Okay, pi by 4 to what? Pi by 2. Please have a look. Okay, so I'll keep okay, no, 1 second. I don't have to write this. I can write this simply as I. Take this thing as whole thing as I. So I can simply write this as I equals to what? I equals to I take the first one as it is, so log sin x will be as it is. So log of sin x, okay, log of sin x with integration of cos 2x. How much is integration of cos 2x? Cos 2x integration is sin 2x by 2. Sin 2x by 2. What's the limit for the first part? Pi by 4 to pi by 2. Is it over, sir? No. I have to use what? A minus sign. I have to use what? A minus sign. Now what now? Please have a look. I have to integrate inside. First take the differentiation of the first part. Log sin x. What is differentiation of log sin x? 1 by sin x for the log, and for sin x we are using chain rule here. Cos x, sir. For sin x it is cos x, sir. This whole thing is only differentiation. Now what is the next thing? Integration of this part, cos 2x. How much is that? Simply, if you want, I can write it over here. Okay, dx is there. Limit will remain as same. Pi by 4 to pi by 2. Okay. Now let's look at this. I get if you put pi by 2, it will become what? 1. If you put upper limit in the first bracket, it will become what? Sin x will become 1. Sin of pi by 2 is 1, and log 1 is 0. So the whole thing is 0. Correct. Now check pi by 4. If I take pi by 4, what am I going to get, bacha? If I take pi by 4 for the lower limit, minus. So this will be what? Log of pi by 4. It will be log of sin pi by 4. No problem there. But over here, sin 2 times pi by 4 is how much? Please check. Sin 2x is there. Sin 2x. It means what? Sin 2 times of pi by 4 upon 2. Yes or no? How much is this? Sin, how much is that? Simply please check. 1 by pi by 2 only. Okay. Shall moving on. Moving on. How much is this, bacha? Please have a look. I have to integrate it over here. Pi by 4 to pi by 2. Okay. And how much is this? 1 upon sin x cos x. Take this out. This will become what? Sin 2x by 2. So 2 is there in the denominator as it is. Okay, as it is. What is going to be sin 2x? I can write it as the sin 2x. Same thing, no? Integration of this cos 2x will be sin 2x by 2. So I can write it as what? 2 sin x cos x. 2 sin x cos x. 2 sin x cos x with again will come what? Dx. Sin x gone. 2 and 2 gone. Okay, 2 and 2 gone. Please have a look. My integration I will look like this. 0 is gone now. I'll take this minus sign. What is it? Log sin pi by 4. What is log sin pi by 4? Sin pi by 4 is 1 by root 2. So it as minus log of 1 by root 2. Minus log of 1 by root 2. Okay. What about this? 2 is there here, right? 2 is there. So I can take this 2 outside. I can take this 2 outside as 1 by 2. And this will become what? Tell me. Sine of 2 times of pi by 4 is time of pi by 2. So simply what? Simply 1. First part is done. Minus sign. Please have a look. I am getting what? Integral of pi by 4 to what? Pi by 2. And how much is this? Cos times cos. So cos square x. Cos square x dx. Okay. This part is clear. This part is clear. Now have a look over here. Multiply 2 on both numerator and denominator. What am I going to get, bacha? just for the first part. Multiply here minus 2 by 4. Minus 1 by 2 is there. I am writing it as minus 2 by 4. Any problem? No sir. Just multiplying 2 on both sides. Log of 1 by root 2. This is done. Now please have a look. This will become integration. Same thing will be there. I can transform this as 1 plus cos 2x the whole thing by 2. Because cos 2x is 2 cos square x minus 1, the formula. Cos 2x is 2 cos square x minus 1. So cos square x will be what? 1 plus cos 2x by 2. What's this limit? No change sir. No change over here also. Pi by 2. And what is this? Dx. Okay. I can separate the limit for individual terms. 1 by 2 is a constant. I can take it outside. Please have a look. Now I am taking this minus 2 inside. I am writing it as 1 by 4 as it is. I am taking the coefficient 1 by simply minus 2 as log of 1 by root 2 to the power minus 2. How come sir? Because power of the log can be taken as coefficient. Same way ulta is also possible. Coefficient of the log can be taken as power. Sir, why 1 by 4 is left here? The whole thing is coefficient. I wanted to use only minus 1 by 2, minus 2. So that's why I took minus 2 as the power on this side. You'll see now. Now this sign is minus. Second part, I'll integrate 1 by 2 is a constant, so I can take 1 by 2 outside the integration. Now integrate, what is left now? Please check. There will be simply pi by 4 to pi by 2. I have this as 1 plus cos 2x dx. Yes or no? Close the bracket. Yes or no? Very, very simple. Let's have a look. Anything we can do it on this line only. I equals to, please have a look now. 1 by 4 will remain as it is. Power is minus means what? I can take reciprocal of the number. It will become root 2. Root 2 square is how much? Just 2. So this will become what? Log of 2. I will repeat. Power is minus 2. It means what? I have to take reciprocal of this thing. It will become root 2 in the numerator. 1 by root 2 will become what? Root 2. Square of root 2 is how much? Simply 2. Okay. Minus sign. What I have over here? I have first thing as 1 by 2. Okay. Now check. Integration of 1 is how much? Integration of 1 is how much? Sir, x. Okay. And what about cos 2x? Sir, sin 2x by 2. What's the limit? Pi by 4 to pi by 2. Close the bracket. This is my integration done. There is no integration left over here. So I'll rewrite this whole thing in the next step. I write this as, please have a look, I equals to, I have 1 by 4 log of 2. 1 by 4 log of 2. Okay. Now over this side minus 1 by 2, minus 1 by 2, x plus sin 2x by 2, x plus sin 2x by 2, sin 2x by 2 to the limit is what? Same thing, pi by 4 to pi by 2 like this, pi by 4 to pi by 2 like this. Okay. Let's continue now. 1 by 4 is there with the log 2 minus 1 by 2 is there. Okay. Now take pi by 2 here for the upper limit. It will become what, bacha? It will become simply what? Pi by 2 minus, sorry, plus sine of pi by 2 times 2 is what? Pi. So this is 0. This part will be 0. We'll see that later. Okay. What about next one? Pi by 4 will use, so minus sine pi by 4. Okay, because I'm using the lower limit now for x. And what about this? Plus sine of 2 times of pi by 4 is how much? Sine pi by 2. 2 times of pi by 4 is how much? 2 times of pi by 4 is pi by 2. Okay, upon 2. Okay, please have a look. So 1 by 4 log 2 minus 1, this is what? 1 by 2 pi by 2. How much is this? Plus 0, because sin pi is 0. Okay, minus pi by 4. Okay, what about this? Sin pi by 2 is simply what? 1. So minus 1 by 2. Alright, chaliye. 1 by 4 log 2 minus 1 by 2 times of pi by 2 minus pi by 4. 90 minus 45, again 45. So pi by 4. What about this? This is minus, so minus 1 by 2. How much is this? Open the bracket. 1 by 4 log 2 plus, sorry, forgive me. Yeah, plus 1 by 2. This minus and this minus become what? 1 by 2 times of 1 by 2. So how much is that? Simply 1 by 4. 1 by minus 1 by 2 and minus 1 by 2. Simply 1 by 4 and this angle minus pi by 8. This is my final integration. Please have a look. Final answer. Okay. Please see from the beginning. I hope this is visible. Okay. There is no substitution in this particular case. Simpler integration for definite kind. Okay. Very good question. Very good question. Okay. Chali. So first, what was the integration? First I did pi parts over here. Then applied for the formula for cos square x as 1 plus cos 2x upon 2. Okay. Same thing we got over here and continued the with the limits. Okay. Just one transformation I have done here is I have taken minus 2 over here. Okay. And taken into the numerator side and got the result as log 2. Got the result as log 2. Visible? This also is visible, sir. Question number 4. X tan inverse of x 1 plus x square 3 by 2 0 to 1. Limit is 0 to 1. Okay. Let's see. So looking at this question, I feel this is going to be very simple to substitute. I can take tan inverse of x as t. Please check. It will work out. Tan inverse of x is t means what? It means x equals to tan t. Tan t. Differentiate now. You will get what? You get 1 equals to sec square t dt by dx. So what do you get now? You get dx equals to sec square t dt. First thing is done. Okay. Now you need the limit change. So check for lower limit now. Now when x is what? 0. When x is 0, what is t? Check now. When x is 0, t is what? Simply 0. How, sir? X tan inverse of 0 is 0. So tan inverse of 0 is 0 means t is 0. What about next one? When x is 1, upper limit. When x is equal to 1, what is my t? Tell me. Tan inverse of 1 is how much? Pi by 4. I'll put x as 1, tan inverse of 1 will be pi by 4. So limits are what now? 0 to pi by 4. Okay. Can you transform the limits now? Write this integration as 0 to 1. 0 to 1. X will be what? Tan t. X will be simply tan t. What about this tan inverse of x? Tan inverse of x will be t. T. And what about this? Dx. Sec square t dt. Will be what? Sec square t dt. Okay. What next? 1 plus x square is there, right? 1 plus x square is what? 1 plus tan square. 1 plus tan square t power 3 by 2. Power 3 by 2. Yes. Have a look. I equals to 0 to 1. Not 1. 1 is changed, right? I have to change the integration. No. Pi by 4 I have to write. This is pi by 4, bacha. Pi by 4. Have a look. Okay. Pi by 4. Alright. Please have a look. What will this become? T tan t sec square t dt upon 1 plus tan square t is how much? It's simply sec square t. It's going to be sec square t to the power 3 by 2. 2 goes out. I get sec cube. Please check. I get what? I equals to 0 to pi by 4. 0 to pi by 4. This is t times of tan t sec square t upon sec cube t dt. Check this out. I have only sec left. Okay, only sec left. Now what's this going to be? What's this going to be, bacha? I equals to integration from 0 to pi by 4. 0 to pi by 4. Okay. T times of tan t is there, right? Tan t. So sin t upon cos t. I have here denominator as also sec t dt. Have a look. Have a look. I have t tan t and sec t. T tan t and sec t. T tan t is what? Sin t by cos t. Sin t by cos t. Okay. And sec t will become what? This will become what? Simply 1. So what I am getting now? My integration is equals to I integration with 0 to pi by 4. What is this? T sin t dt or not? T sin t dt or not? Yes. Now integrate this by parts. You have to use again. By parts. Use this by parts condition. So what is the first one? Islet, right? The preference order is islet, right here. ILATE. Algebra has preference over trigonometry. ATE, right? So I can take this as 1 and take this as 2. Okay. What will this look like? Please tell me. I'll keep 1 as it is, so t will be as it is. Okay, sin t differentiation will be, integration will be what? Minus cos t. Okay, this whole thing is in the limit 0 to pi by 4. Okay, now I'll take a minus sign for the parts. Okay, second part will be what, bacha? So integration of the first differentiation, t differentiation is what? Simply 1, and integration of sin t is what? Minus cos t. Okay, this whole thing with dt is there. Okay, dt is there. Chaliye, from the limit will remain same, so 0 to pi by 4 will be here. So let's see the first part in the limit substitution. I'll get what? I'll get this as, there's a minus sign, so I'll just keep this minus sign over here. So minus pi by 4, minus pi by 4, what is this? Cos of pi by 4 is how much, bacha? Simply 1 by root 2, simply 1 by root 2, okay, simply 1 by root 2. What about this one? 0, so cos 0 will be what? But I'll have 0 also here, no? T as 0 is there, so it will become what? Simply minus 0, because lower limit will be what? 0, so 0 into anything will be 0. What about this integration? Integration of minus cos t, please have a look. So I'll put a minus sign over here. I'll integrate minus cos t, I can take minus sign common, they will become plus. See here, this minus and this minus will become plus. I'm taking this minus common, with this minus will become plus. So plus, integrate cos t, I'll get what? Simply what? Sin t again. Yes, sin t with the limit 0 to pi by 4. 0 to pi by 4, how much is that? Please have a look. I get it as, my integration I is equals to minus pi upon 4 root 2 plus what? 1 by root 2. Correct, no? Please check. Yes. Because pi by 4 will be 1 by root 2 and 0 will be 0. Please check the LCM here. LCM is 4 root 2. And what is this? Minus pi plus 4. How much is the answer? 4 minus pi upon 4 root 2. This is my integration I. Any option like this? Please have a look. 4 minus pi upon 4 root 2. Option number C. C is the right answer. C is the right answer. Any problem over here, sir? Any problem over here? Very, very simple question. Okay. Alright. Just take in tan inverse x as t. X goes to tan t. I have to take the inverse on the other side. When I take this, I get differentiation over here as dx equals to sec square t dt. Okay. Then the limit conversion for the upper limit, lower limit. Substitution the limit, same thing, and use this in the given transformation using the identity. We get what? Sec square. We get what? T sin t integration, which will be by parts we can use. By using by parts, we get the answer as 4 minus pi upon 4 root 2. 4 minus pi upon 4 root 2. I hope this is understandable. Okay. Let's move on to the next question. Okay. Chali. Visible. Question number 5. Question number 5. Actually, this I can give you as homework. Okay. This I can give you as homework. But I don't remember the answer. Answer should be what? Same question, right? Exact same question. So just give me your homework. And comment your answers. Comment your answers, like whether it is A, B, C or not. So comment your answers. I'll tell you if it is. I'll cross check the solution later. I think it should be. I don't remember right now. I have to solve it to know the answer. So do one thing. Use it. How will you use it? I'll give you some hint. I'll give you some hint. Take what? Sin inverse of x equals to what, bacha? Simply t. Okay. Same thing will become x equals to sin t. Okay. Take differentiation will become what? 1 equals to cos t dt upon dx. What is my dx then? Dx equals to cos t dt. Please solve this. Please solve this. Okay. From here, change the limit also and get the answer. Change the limit and get the answer. Okay. Chaliye, moving on. Okay. Yes. Homework. Please solve this question. Very, very important. Same question I've solved here. If you are having this doubt, please check. Similar question I've solved here. Okay. Very similar question. So I want you to solve this from your side. Give some effort and let me know. Okay. Now this one I will solve. This one I'll solve. Chaliye. What are they saying? Integrate from tan cube x sec square x. Okay. Tan cube x sec square x. Let's take the substitution first. I can take what? T equals to, if I take tan x, differentiate now, I'll get dt by dx equals to sec square x. That is there over here. Okay. Take this on this side, I'll get what? Dt equals to sec square x dx. Okay, now change the limit, when x is 0, my t is what? Tan of 0, how much is that? 0. When x is pi by 4, my upper limit pi by 4, I get what? T equals to tan of pi by 4, how much is that? 1. So my integration will look like this, please have a look. It will become I equals to integration from 0 to 1, upper limit is 1, lower limit is 0, so 0 to 1, okay. This will become what, bacha? T cube, because tan x is taken as t, so t cube, please have a look, tan x is t, so t cube, sec square dx is what? Simply dt, okay. What are you going to get? Tell me. You're going to get t power 4 by 4 starts from 0 to 1. What is the answer? 1 by 4. Answer is 1 by 4. I hope you understood this, right? 1, if you put it here, 1 power 4 is 1, 1 by 4. If you put 0, you'll get 0. So answer is 1 by 4. Yes? Okay. Moving on. Okay. So not all the questions will be difficult, bacha. Some questions are difficult. Yes, that is the nature, right? That's how the paper will be designed as well. And I take difficult question on purpose because, you know, when I'm solving difficult question, I try to give more information in that question. Okay. So my goal is not to just make you solve the papers. My goal is to make you understand the concept also through the questions. Why questions, sir? If you have a question, if you have this doubt as why questions, sir? Because you are preparing for what? A competitive examination. What are they asking? Only questions. So you have to work on problem solving skills. You have to work on speed also. How fast you can solve the problem. So first you have to learn all the concepts, then you can work on speed. So I am working on your concept part. Speed you can practice and practice. Same thing you can keep solving again and again. The thing is, no, if you're solving same question again and again, people think it's like memorizing the question. No, you're memorizing the steps what is required to get to the next level. You're trying after solving same question over and over again. No, what happens? Your initiation will come directly. You don't have to wait for it to click in your mind. So you'll know what to do next. So your initiations will be very, very, it's like, it'll become as like your reflexes. Okay, you'll become very reflexive to any questions coming to you, any doubts coming to you. You'll have very good reflecting about this questions. Okay, so that's why practice more and more. You'll have a better way to handle the difficult problems as well. Okay, so how will I solve this? If I take 1 plus e power x as t, let's say 1 plus e power x as t, right? Differentiated, bacha, it will become 0 plus e power x equals to dt by dx. So I get dx as dt, ex dx as dt. What about limit change? Please change for lower limit first. Lower limit will be what, bacha? X is 0. X is 0. So x will be 0. What is my t? 1 plus, t is 1 plus e power 0. How much is that? Simply 1 plus 1. How much is that? Simply 2. What is upper limit? Upper limit will be what, bacha? X is log 2. X is log 2. Please put here t plus 1 plus e power log 2. How much is this? 1 plus e power log will be cancelling the effect because inverse function. So 2, how much is the answer? 3. So my lower limit is 2, upper limit is 3. So this integration will become what? Please check. I will become 2 to 3. The integration I will become, if I take this as I, so I will become 2 to 3. And what will this be? Please check. Ex ds will become what? Dt. So dt simply t. How much is that? Ln t. From where to where? 3 to 2. So ln 3 minus ln 2. How much is that? Ln 3 by 2. Log of upper limit, so 3 log minus log of lower limit, which is 2. So difference is there. So we can use the quotient rule in the logarithms. So 3 by 2. Answer is log 3 by 2, option number C. Any problem here? Any problem here? No, sir. Question number 7 is also over. Previous one was also done. Yes, 7 is also over. Question number 8. I think this is visible. Very simple. Question number 8. Okay, sir. Question number 8. How will I solve it, sir? Please have a look. So they are asking us to integrate from where to where? Minus 1 to 1. Minus 1 to 1 for this a square e power x plus b square e power minus x. If you see here, if I take any substitution for this, I don't have e power x in the numerator. So I'll take e power x in the numerator. If I do that, what I'm going to get? Please check. my integration will become I to I. Achha, before that, let me just transform it a little bit. Before using substitution, let me transform it. Before using substitution, let me transform it a little bit. It will become what? Minus 1 to 1, not I, minus 1 to 1, minus 1 to 1, okay. I'll have this as dx, this will be, let's multiply everything with e power x, okay. If I do that, what I'm going to get? E power x over here, I get over here as e power x a square, e power x plus b square e power minus x, okay, that's it. I multiply e power x in both numerator and denominator, no problem there. If I do that, what I'm going to get? Please check. I'll get integration from e power x dx, multiply, take this e power x inside, I'm going to get a square e power 2x. Why like this? Same base power can be added, so x plus x is 2x, over here b square e power 0, because same base power can be added, x minus x is 0, okay. This is b square. Now please look, this is for minus 1 to 1 only, again minus 1 to 1, so how much is this? So e power x dx upon a square e power x the whole square. How, sir? E power 2x is there, I can write it like this, no? Plus b square. Let's take this do one thing, bring this a square on this side. Bring this a square on this side. If you do that, so I'm asking you to take a square common basically in the denominator. If you do it like this, you'll get what? Minus 1 to plus 1. Minus 1 to plus 1, numerator will remain same, so e power x dx, okay. I'm asking you to take it common. A square is taken common. What is left here in the first term? Sir, nothing is left. E power x the whole square is left. What about the second term? Sir, it will be b square upon a square, sir. How come? Multiply it. A square times, so this will remain as it is. Multiply a square with this, a square will cancel, will become b square, okay. Chali. Look at this part. My integration I will become what? Tell me. It will be 1 by a square, it will be constant, so take it outside. 1 by a square is constant, I am taking it outside. From where to where? Minus 1 to 1, e power x dx, okay. And how much is this? E power x the whole square plus b by a the whole square. Yes, okay. Now let's do one thing. Take t equals to e power x. T equals to e power x. What's the differentiation, bacha? So dt by dx equals to e power x only. So e power x dx will become what? Tell me. This will become what? So I will have this as dt equals to e power x dx, e power x dx, e power x dx, okay. I have to transform the limits also, you will see in the next step. So let me write it over here as my integration. So I have taken few things over here. I have taken t as e power x, okay, and I also taken d, now I have got it as dt equals to e power x dx. I will show you from this side. Dt equals to e power x dx, okay. Now what is the condition? Minus 1 to 1. So my lower limit is what? Lower limit is x equals to minus 1. Put it here. My t will become what? My t will become e power minus 1. How much is that? 1 upon e. Same way. Upper limit. Upper limit is what? X equals to 1. So t equals to what? E power 1, simply what? E. Simply what? E. Now transform this integration. I will become what? 1 by e to e. 1 by e to e. Lower limit is 1 by e. It's not c, it's e. Please have a look. It's e. Okay. What next is there? The function transformation. This will become but simply dt. Simply dt. So write it as dt. What is it? E power x is t. Okay, it will become what? T square plus b by a the whole square, and a square is outside as constant. Have a look. A square is outside as constant and b by a the whole square. Check the formula. 1 upon a square plus x square. How much is that? Tan inverse of x. So I can write this as 1 by a square is a constant. 1 by a square is a constant. Okay. It will become simply 1 by a. How much is 1 by a? Tell me. Sir, 1 by b by a. No, because this thing is 1 by a. Remember this? Okay. Tan inverse of t upon what bacha? B by a. Same thing, B by a. From where to where? 1 by e to e. 1 by e to e. Okay. Can I take this constant outside? Please have a look. So I'll get this I equals to 1 by a square is outside. I'm taking this b by a also outside in the denominator only. So b by a I'm taking like this. Okay. What I'm gonna get? Tan inverse. What is this? At by b. Please check. A will go up. So At by b. Tan inverse of At by b from where to where? 1 by e to e. 1 by e to e. Okay. This is cancelling out. So 1 by ab, the constant term. Okay. Tan inverse of what? Upper limit. Tan inverse of a by b minus tan inverse of a by be. Yes or no, sir? For upper limit, e is in the numerator, right? Just e is there. So I'll write t as what? E will become at by, this is, please have a look. This is at, okay? This is at. This is at. I'm writing t as e, right? So t will become a by b. Over here, t is 1 by e. It means 1 by a. So a upon b will come. That's my answer, I guess. Please have a look. 1 by ab, 1 by ab, a by b, and a by be. Okay, a by b and a by b. Option number A is correct. Yes, please have a look. Okay. 0 to pi by 2, 1 by 1 plus 3 cos square x. Cos is there, means, sir, I can get something with sec square. I can get something with sec square. Let's try. So let's try the identity first. How can we make this identity sec square? Divide everything by cos square. Let's see, something will happen. So this will be I. My integration I is given simply as I equals to, limit will be same, 0 to pi by 2. Okay. I'm doing this 1 upon cos square x divided by 1 upon cos square x plus 3 cos square x upon cos square x dx is as it is. So I'm dividing everything by cos square x, no problem. 0 to pi by 2, 0 to pi by 2, how much is the numerator going to be? Sir, sec square x dx. Denominator, sir, sec square x plus 3. How come, sir? Cos and cos will cancel. So sec square x will plus 3 is there. Denominator. Put the value of sec square as 1 plus tan square. Now have a look. Sir, sec square x dx upon what, bacha? Sir, 1 plus tan square x plus 3. How come, sir? Sec square is 1 plus tan square, that's why. Okay. So I can write this as, my integration I is equal to 0 to pi by 2. This will become what? Sec square x dx upon, please check, tan square x plus 4. Yes or no? 1 plus 3 is 4. Okay. Now the substitution will come. Take this as t equals to tan x. T equal to tan x. How much is that? So dt by dx equals to sec square x. How much is that, sir? dt equals to sec square x dx, sir. Okay. Change the limits now. Lower limit. How much is it? It was 0. So when t is equals to what? Tell me. Tan of 0, how much is that? Simply 0. What about this upper limit? Upper limit is t equals to tan of, how much is that? Pi by 2. Pi by 2. How much pi by 2? Infinity. Tan pi by 2 is infinity. I have applied t equals to tan x for both upper limit and lower limit. I get answer as 0 to infinity. Now this integration will become what? Please have a look. 0 to infinity. So infinity. Sec square dx will become what? dt. This will become what? T square plus 2 square. 4 is what? 4 is what? 2 square. dt by t square plus 2 square. So a square plus b square, a square plus x square. Sir, simply what? Simply what? tan inverse of x. So 1 by 2, why 1 by 2 sir? Because 2 is what? A. So 1 by a tan inverse of x by a. What is x? T. So t by a. The limit from 0 to infinity. 2 is 1 by 2 is constant, I can take it outside. So my I will become what? 1 by 2 is constant, I can take it outside. Tan inverse of infinity minus tan inverse of 0. Please check. Upper limit minus lower limit, how much is this bacha? So simply 1 by 2, infinity is what? Pi by 2, right? Tan inverse of infinity is pi by 2. Tan of pi by 2 is infinity, so tan inverse of infinity is pi by 2. Tan inverse of 0 is simply 0. How much is the answer? Pi by 2 times of 1 by 2. So pi by 4. Please have a look. Pi by 2 is there, into 1 by 2 is pi by 4. Option number B, sir. Have a look. Yes. Divide everything by cos square to get the sec square in terms of sec square. Why, sir? Because identity of sec square becomes easier to solve. Okay, I can replace sec square again with 1 plus tan square. That's what we did in this step. 1 plus tan square, this sec square becomes 1 plus tan square. I've done this here. Once I do that, I get what? Tan square plus 4. I take the substitution as x equals to what, bacha? X equals to tan of t equals to tan of x. T equals to tan of x is my substitution. I got the differentiation for dt and got the limit change also. After changing the limits, I get the limit as 0 to infinity. I put it in the integration like this: 0 to infinity dt upon t square plus 2 square. The formula of what? 1 upon a square plus x square is how much? Tan inverse of x by a with 1 by a. So 1 by a tan inverse of x by a. Okay. Answer is pi by 4. Answer is pi by 4. Have a look. Moving to the last problem of the day. What are you going to do? Same thing, right? Divide by cos square, make tan square, sir. So what is there? Cos power 4 is there. Check here. 0 to pi by 4 sin x cos power 4x plus sin power 4x is there. Same thing we're going to do. Divide by cos power 4 because I'll get what? Sec, and that term will make our work easier. Let us see, sir. Okay. Let us see. So if I integrate this, integration I will be what, bacha? Divide everything by cos power 4. I get what? Sin x cos x divided by cos power 4x. Cos power 4x divided over here. So cos power 4x upon cos power 4x plus sin power 4x upon cos power 4x. And how much is this? Simply dx. Please check what is this going to be. I equals to 0 to pi by 4. 0 to pi by 4. This will be what? Cos cube will be left here. 3 is left now after cancellation. It's not x cube, okay? It looks like x cube, but it is not x cube. It is simply what? It is simply 3, bacha. Because there is a cos x, no? So I have cancelled this with. So I get 3 here. What is left now? So I can take, if you see here, sin by cos. So I can write it as sin x by cos x. Sin x by cos x. And write this as 1 by cos square x divided by, how much is this? 1. How much is this? Tan power 4x dx. Please check. Sin by cos, how much is that, bacha? So I will become 0 to pi by 4. And how much is this? Sin by cos is, so simply tan. Simply tan. Okay. What about 1 upon cos square x? It will be sec square x. It will be sec square x, sir. 1 by cos square is sec square x. Okay. Chaliye. What is this? 1 plus, write it as tan square x the whole square dx. How come, sir? Tan power 4 is there. That's why tan square x the whole square is same thing. Now the substitution part. Take this, sir. T equals to tan square x. Differentiate it. You get it as dt by dx equals to 2 tan x sec square x. 2 tan x sec square x. Right, na? 2 tan x for this polynomial part, and for tan x I'll get as sec square x. Okay. So what is my dt value? Dt is 2 tan x sec square x dx. Sec square x dx. Okay. This is my dt value. So I'll substitute 2 tan x sec square x. So 2 is missing, right? 2 is missing. I'll put it as dt by 2. No problem. No. Tan x sec square x dx is there. Please have a look. Tan x sec square x dx is here. Tan x sec square x dx is there. I can write it as dt by 2. So I'll replace this by dt by 2. So I'll before that, let me change the limit also. So I write it as x equals to what? Upper lower limit. X is 0. T is tan square of 0. How much is that? 0. Pi by 4. X is what? Pi by 4. T is what? Tan square of pi by 4. Pi by 4 is how much? Tan pi by 4 is 1. 1 square is simply what? 1. My limit and is changed now. Have a look. Integration I becomes dt by 2 0 to 1 1 plus t square. Check here. For this part I wrote this as dt by 2 because 2 will come over here. So dt by 2, okay, and this will become 0 to pi by 4 will become what? 0 to 1, so that is also done, and this is going to become 1 plus tan square x is what? Simply t, so I'll get it as t square, okay, same thing. So bring this over here, I'll get what? I'll get my integration I equals to 1 by 2 from where to where? From 0 to 1. This is simply what? Dt upon 1 plus t square. How much is? Yes, now what is this? Again, I equals to 1 by 2 tan inverse of t from where to where? 0 to 1. Because 1 plus t square is what? Tan inverse. Put here. I equals to 1 by 2. How much is this? Tan inverse of 1 minus tan inverse of 0. How much is this? I equals to 1 by 2 times of pi by 4 minus 0. How much is this? I equals to pi by 8. Any option like this? Any option like this? Please have a look. D. D. Extremely simple. Extremely simple. Yes. So this is it, bacha. This is it for your different integrals using substitution. I hope you learned a lot in this session. I hope you enjoyed the session. I hope you are working hard with me. Okay. I know the chapter is difficult. I know the questions are challenging, but that's how it is. Okay. Challenges will be there. Okay. We have to deal with it. We have to work hard to get over it. Okay. So with this, I'll end up the session today. I'll conclude the session today. In the next session, we'll talk about properties of definite integral. Okay. So prepare, solve the questions till this slide. We have done part 7. We have done total 7 sessions in the integration. We're gonna keep it. I told you I'll come with one last session for the concept part, which will be what? Your on the basis of your properties of definite integral. Then we'll start the revision of integration. Sir, why we just did right now? Why revision? I want to solve more questions. That's why. Okay. So we'll do revision and we'll solve some PYQs also. We'll do revision and some PYQs. We'll not take all the PYQs. Some PYQs will also solve in the session. Okay. Chaliye. So with this, we'll end the session today. I hope you are working hard. Keep smiling, bacha. Whenever you are having a tough time, try to face it very positively. Okay. Keep working hard. Any queries, anything that you want to ask me, put in the comments. Okay. I have given one question as homework. Similar question I've solved. Solve it and give me the answer. I'll cross verify from the after I solve it, and then I will let you know whether your answer is right or wrong. If you have a doubt, we'll solve that question again in the coming sessions. Okay. So with this, I would like to conclude the session. Please take care of yourself. For now, take care. Bye bye. See you in the next session.